Okay, guys, welcome back. I know we've been doing limits from graphs. We were introduced to it right on Monday. We've had a review day of it where we've been able to meet in class, and I just want to do one more day, okay, of this to make sure we all feel really good. A couple of reasons. One, it's just a really big topic, in the sense that it's really important that you understand the foundations of this and what limits mean and how to read them from a graph. So I want to make sure we have enough time to work through that. And second of all, just being mindful of the distance learning right now and not going too fast, too quickly. I care more about your understanding than getting through as much material as we can. So I promise, if this is something or you're feeling like this is too easy at this point, I promise you will get to some new stuff next class. But for now, I want to just do one more day of it. So here's what we're going to do. Hopefully you've downloaded worksheet number 4 off Canvas already, which is this worksheet here. It's got 18 limit questions. So what I want you to do is actually pause the video and take however long you need to work through those 18 problems. Once you are done, hit play, and I will go through the answers to all 18, and I'll kind of give a little explanation for each one too. So if you do get one wrong, you can hopefully get a little explanation as to what you needed to do there. So pause the video now and then hit play again when you're done and to check all your answers. Okay, hopefully you've done all of them and you've got some answers here. Let's start working through them. So question number 1 says f of -2. Okay, that's actually not a limit. It's just saying what is the value of f of -2? Yep. What is the value of the function at -2? And if you come over to the graph, you want to look for where your circle is, where your filled in dot is. And actually our filled in dot, right, is right here. So what is the value of the function at -2? It's actually 3, right? It's 3. If you said 1, the reason why it's not 1 is because we have an open circle there. And since it's an open circle, that means, right, the value does not exist at that singular point. The point actually exists, right, at that closed circle at 3. Number 2 says, what is the limit as x approaches -2? And it has a little plus sign. That means it's coming from the more positive numbers or from the right side. So if I'm following the road, right, and approaching -2, an x value of -2, I'm approaching from that side. Where is that arrow pointed? Well, the arrow is pointed towards 1. Notice, even though the value of the function at -2 is +3, okay, the limit is +1 because that's where the arrow is pointed towards, right? Is where the graph is approaching. Number 3 says, what is the limit as x approaches -2? And since there's no little plus or minus to the top right of it, it's asking me for the limit as I approach both sides. Well, I already know what it is as I approach from the right, it's 1. As I approach from the left side, where is that arrow pointed? It's also pointed towards 1. Since they're both pointed towards 1, that means this overall two-sided limit is +1. Okay? All right, so let's go on to the next line. I'm actually going to just erase what we've done here so you don't get confused. We can erase that. Okay, so the next one, what is the limit as x approaches -1 from the positive side? So -1 from the positive side or more positive side, right? So that would be here, and I'm approaching an x value of -1 from the more positive side. Where is that arrow pointed? What y value? 0. Number 5, what is the limit as x approaches -1 from the negative side or the left of f of x? That means I'm coming from the left, going towards -1. That is also pointed towards 0. Okay, what is the limit as x approaches -1? There's no little plus or negative sign to the right of it, which means it's a two-sided limit. So where are both those arrows pointed? They're both pointed towards 0. And you know what? I didn't even need to look at the graph. Why not? Because I actually have, right? I actually have what the limits are doing from both sides. So if I know both one-sided limits are both pointed towards 0, then the two-sided limit, number 6, must be 0 as well, right? Because the two-sided limit just comes from where the two one-sided limits match. Okay, so that allowed me to know, without even looking at the graph, that the limit as x approaches -1 is indeed 0. Okay, all right, let's go on to the next ones. Erase that. All right, so what is the limit as x approaches +1 from the positive side? Okay, so as I approach +1 from the positive side, I start to the right of it and I follow that road. That arrow is pointed towards a positive y value of 1. Let me go back to green to stay consistent. So the limit as I approach a positive x value of 1 is a y value of 1. But what about the limit as x approaches 1 from the left side? That's what that little negative to the top right of it looks like. So as I approach 1 from the positive side, where is that arrow pointed? Well, it's pointed towards a y value of 2. Okay, it's pointed towards a y value of 2. Now, number 9 says, what is the limit as x approaches 1? That's a two-sided limit. So I know my 1 coming from the right side is 1, coming from the left side is 2. Since they don't match, then I know that my overall limit does not exist. So you just write DNE, does not exist. And again, I know that because the two one-sided limits here, right, do not match. And if they do not match, I automatically know that the two-sided limit does not exist. Okay? Let's erase all that. Maybe erase some of these arrows, clean it up. Okay. So number 10, f of 3. Notice this is not a limit question. It just says asking for what is the value of the function when x is 3. Well, when x is 3, we're at this point up here. It actually is an open circle. And if it's an open circle, that means the point does not exist, DNE. However, number 11 asks for the limit. And the limit does not care what the value is. It only cares about what it's approaching. So it's saying, what is the limit as x approaches 3 from the positive side, or the bigger numbers? So as I approach 3, where is that arrow pointed? It's pointed towards a y value of 5. Number 12, what is the limit as x approaches 3 from the left, or the more negative side? That takes me on this road as I work my way towards an x value of 3. That also brings me to a y value of 5, even though the point doesn't exist. Again, it's just where it's pointed. It's pointed towards 5. Number 13 says, what is the limit as x approaches 3 of f of x? That is a two-sided limit. And again, okay, do I actually need to look at the graph to figure this out? I could if I wanted to, but by looking at my answers to 11 and 12, since I got 5 for both one-sided limits, I know the two-sided limit must also be 5 as well. Okay. Let's erase this. All right, number 14. What is the limit as x approaches -4 from the right side? Interesting. So let's take a look at this. You may have struggled a little bit, and that's okay. It looks like as I come from the right side, right, as I come from the right side here, my arrow almost looks like it's approaching an asymptote, a vertical asymptote. And you can assume a vertical asymptote at that point. Okay, so if we assume there's a vertical asymptote here that graph doesn't touch, because it looks like it's becoming almost vertical. Okay, where is that arrow pointed? Okay, where is that arrow? Is it ever going to stop? Well, it's not going to stop because it can't touch the asymptote. And since there's no end point and there's an arrow at the end, we're assuming it's going to go up forever. And if it goes up forever, what value is it actually approaching? It's approaching infinity, right? The y value, it's going to go up forever. It's never going to stop. An arrow indicates that it goes on forever. So if it's never going to stop, okay, if it's never going to stop, we would say it's infinity. Number 15 says, what is the limit as x approaches infinity? If we think about where is x approaching infinity, that's out in this direction, right? As the graph goes forever in that direction, where is it? What y values is it approaching? Well, if I come to the right of it, and I follow the graph here, it looks like it's flattening out towards a horizontal asymptote. You can imagine a horizontal asymptote here. Where is that horizontal asymptote? Well, it's at y equals 0. So what y value is the graph approaching as we go out infinity to the right? As x approaches infinity, the graph itself, the y values are getting closer and closer to 0. Right? They're getting closer and closer to 0. 16 says, what is f of 1? Again, not a limit question, a value question. And it's saying, all right, what is the value of the function at 1? We're looking for the closed circle. The closed circle is there. So what is the value at 1? Well, it's a y value of 1. Okay, it's 1. Let me erase some of what we've done. Okay, wrapping things up here. Number 17 says, what is the limit as x approaches -3? Well, that's a two-sided limit, so I need to come from both sides. So as I approach -3 from the left, it's pointing towards a positive value of 1. As I approach -3 from the right side, notice it's a horizontal line at 1. Both arrows are pointed or converging at a y value of 1. And 18, f of -4, what is the value of the function at -4? Well, we just said a minute ago, we can assume a vertical asymptote here. And we know at vertical asymptotes from our work on rational functions that no value exists on the vertical asymptote. So if no value exists at the vertical asymptote, we would say that f of -4 does not exist, or DNE. Okay? All right, so hopefully that helped a little bit if you were struggling a little bit, and if you are feeling good about it, hopefully you got them all right. So your homework tonight, okay, is to work on and finish worksheet number 5. It just wraps up limits from graphs. I do want you to check your answers with your group. Okay, check them in your group, and then tomorrow we will take a look at them in class real quickly. Okay, thanks.